We're going to take a look at how you can use your even and odd identities when finding exact values on the unit circle. So to remind you, your even identities are your cosine and its reciprocal. So the cosine of negative x is the same thing as the cosine of x. Remember that this has y-axis symmetry. And your odd, secant. And then your odd functions are everything else. So your sine of negative x is the opposite of sine of x. So, and on its reciprocal, which is cosecant. And then you have tangent. And then you have cotangent. So those, and this is origin, symmetry about the origin, or both y and x-axis. So for example, if I want to use this, say we have the secant of negative 120, and I want to use my even and odd identities to solve this. Well, secant is an even function. So that means that the secant of negative 120 is really the same thing as the secant of 120. So when I do the secant of 120, that's in the second quadrant. It has a 60-degree reference angle. That gives us the point 1/2 root 3 over 2. We went left and up. So left is negative, up is positive. The secant's the reciprocal of cosine. Cosine is the x value, so I'm thinking flip the x value. So I flip negative 1/2 to be negative 2 over 1, which is just negative 2. Now, to show you that this is true, if we had done the secant of negative 120, again, that's a reference angle of 60 degrees. We get negative 1/2 is what I wanted to write. Okay, let's try again. Negative 1/2 and then negative root 3 over 2. The secant's the reciprocal of cosine. Cosine is the x value, so you're thinking you want to flip the x value, which is negative 2 over 1, which is negative 2. So both of them end up being the same because your x values in both of these quadrants are the same. They both go a negative direction. Okay, that's where it comes from. Okay, so we're just using the even and odd identity to get to another equivalent expression for it. So if we look, for example, at the sine of negative 45 degrees, sine is odd, which means that it's the opposite of the sine of 45, right? So then we can find the sine of 45. If we look at 45, that gives us root 2 over 2, root 2 over 2. You're putting your middle finger down, so you have 2 fingers on the left, 2 fingers on the right. Then we went right and up, so both are positive. And since both are positive, the sign is going to be positive. The sign is the y value. So we take positive root 2 over 2, but we're timesing that by a negative, so then it's negative root 2 over 2. Now, just to show you that this is true, if we look at the sine of negative 45, that's in the fourth quadrant, it still is the point root 2 over 2, root 2 over 2, but we have to change the sign. So we went right and down, so it's positive, negative. So then our y value is the negative root 2 over 2, so we end up with negative root 2 over 2 as our answer, which notice is the same as what we got here. So it's just kind of a different way to look at it, but you're using and utilizing your even and odd functions. So if I give you another example, if we have the cosine of negative 225 degrees, cosine is even, which means that it's the same as the cosine of the value that we have. Oh, not 255, 225. Right? So if we take the cosine of 225, 225 is in the third quadrant. The reference angle is 45 degrees. That's your middle finger. It goes down. You do root 2 over 2, root 2 over 2. We went left and down, so both are negative. We want the cosine. The cosine is the x value. The x value is negative root 2 over 2. Okay. On the rest, I'm going to forego showing you why it's true on both of them, but that just so you had an idea on the first one why it's true, that is how you would get it. So if we look at the next one, we've got the tangent of negative 210. So tangent is odd. That means that it's the opposite of the tangent of the positive angle. So if we take the 210, that's in the third quadrant. The reference angle is 30 degrees. 30 degrees is your pointer finger. It goes down, so you get root 3 over 2, 1/2. And then when you have root 3 over 2, 1/2, you're going left and down. So then you get the tangents, the top of the y over the top of the x, so it's negative 1 over negative root 3. The negatives cancel, I have to rationalize, so times by root 3 on top and bottom, so that gives us root 3 over 3. But you have to remember we found the tangent is, I wanted to color coordinate. It's the negative of the tangent that we just found. Well, the tangent that we just found is the root 3 over 3, so we're going to do the opposite of that, which is negative root 3 over 3. Well, somehow I keep creating these lines, and I don't actually know how that happens. So then this becomes our answer. Now we can do the same thing in radians. So for example, if I take the secant of negative 15 pi fourths, the secant's the reciprocal of cosine. Cosine is even. That means that it's the same value as the positive angle. So this is the same as the secant as 15 pi fourths. Well, 4 goes into 15 almost 4 times. It's just shy of 4 pi. Remember, 4 pi would be over here, so it's going to be in this quadrant. I went doing the twirls because we don't need that part. The reference angle is pi fourths. Pi fourths goes with 45 degrees. 45 degrees is your middle finger, and it goes down. So we get root 2 over 2, root 2 over 2 as the point. We've gone right and down, so we have positive, negative. We want the secant. The secant's the reciprocal of cosine, so we're thinking flip x, because cosine is x. So I'm taking root 2 over 2, and again, you can say root 2 over 2, but just write it from bottom to top. I need to rationalize, so times by root 2 on top and bottom, so that gives us 2 root 2 over 2, but then the 2's can cancel, so we're left with just root 2. So the secant of negative 15 pi fourths, well, I guess I could still say that. The secant of negative 15 pi fourths is the same as the secant of 15 pi fourths, which is root 2. Okay. If we look at another example, we have the cosine of negative 4 pi thirds. Cosine is an even function. Even functions mean that the negative angle and the positive angle are the same values. So the cosine of negative 4 pi thirds is the same as the cosine of 4 pi thirds. 4 pi thirds is a little bit past pi, 1 pi. Remember, all of your odd pi's are to the left x-axis. Pi thirds is your reference angle, which goes with 60 degrees. 60 degrees is your ring finger. It goes down, so you get the square root of 1, which is 1. Everything is over 2, root 3 over 2. We've gone left and down. Both are negative. We want the cosine. The cosine is the x value. We're not finding the reciprocal, so then this would just be, I guess I shouldn't write it there. The cosine of 4 pi thirds, which is the same as the cosine of negative 4 pi thirds, is negative 1/2. Okay. If we look at the cosecant of negative 3 pi halves, this is negative 1.5 pi, so that just puts us straight up. At that point, we didn't go left or right at all. We went up by 1. Oh, that's not what I wanted to do. Sorry, I forgot what I was doing. This is an odd function, so this is the same as the cosecant, oh goodness, cosecant of 3 pi halves, but the opposite sign. So, because it's odd, so it's the opposite of the cosecant of 3 pi halves. So, then if we take the the cosecant of 3 pi halves. 3 pi halves is 1 1/2. This is 0, -1. So we're going to have, we take the opposite. The cosecant is the reciprocal of sine. So you're thinking flip the y value. So if I flip -1, that's still -1. So I get -1, which is +1. Okay. And if, since I had half the picture of the original one anyways, our point was here, you're going to flip this y value, which is still 1, which notice matches our answer over here. If we look at the secant, no, I don't want secant, sorry. The cotangent of -8 pi thirds. Okay? Cotangent is an odd function, which means that it's going to be the opposite of the cotangent of 8 pi thirds, so of a positive angle. So 8 pi thirds is just shy of 3 pi. Remember, all of your odd pi's are to the left. So 8 pi thirds is just shy of 3 pi. Pi thirds goes with 60 degrees. 60 degrees is your ring finger. It goes down. That gives you 1/2 √3/2. And we went left and up, so negative, positive. The cotangent is the x over the y, the top of the x over the top of the y. So we're just going to do the top of the x, which is -1, over the top of the y, which is √3, which gives us -√3/3 when we rationalize. So in our answer, I'm going to write it above here. We have the negative of, and then we're going to put our answer up here. So -√3/3. So that gives us +√3/3 is our final answer. Okay. Now we can also use our coterminal angles to help us out. So for example, if I give you sine of 945, and I want you to write it as an equivalent expression with a value that's between 0 and 360, what we need to do is find a coterminal angle for this one. So if we take 945 and we subtract off 360, then that gives us, that gives us the sine of 585. Well, we want an angle measure that's between 0 and 360. 585 is still past 360. So what we do is we subtract another 360 from there. So if I do 585 minus another 360, that gets us to the sine of 225. So each one of these is going to be the same value. Then I can just look at what the sine of 225 is. That's 45 degrees is the reference angle. That's your middle finger that goes down. That's your point √2/2, √2/2. It's left and down, so both are negative. We want the sign. The sign is the y value. There shouldn't be an equal sign right there. The sign is the y value, so we take -√2/2. Okay. So that's kind of how you can use your coterminal angles. Sorry, I forgot what I was talking about. So if we try another one, if I give you the cosecant of, no, actually, let's do the secant of -780. Right, so on this one, we still want an angle that's between 0 and 360. This angle is more than one time around negatively, so we're going to have to add more than one. So if I add 360, this would be the same as the secant of -420. That's still past 360. We're not at a number between 0 and 360. I have the secant of -60. That's still not between 0 and 360, so I have to add another 360. So this would be the secant of 300. Okay, so what we're doing is we're trying to write an equivalent expression with an angle that's between 0 and 360, and then we can evaluate it. So then 300 is in the fourth quadrant. Your reference angle is 60 degrees. 60 degrees is your ring finger. It goes down. That gives you 1 on the left side, and then 3 on the right side, so 1/2 √3/2. You've gone right and down, so positive, negative. The secant's the reciprocal of cosine. Cosine is the x value, so we're thinking flip the x value. So I write 1/2, or no, I say 1/2, but I write it as 1 starting at the bottom and then 2 on top, so I get 2. Which 2/1 is just 2. So we simplify it to 2. So then that gives us our value. Now you can still do the same thing with radians, except for instead of adding and subtracting 360, we want to add and subtract 2 pi, because remember 360 and 2 pi are coterminal angles, not coterminal, are the same in the two measuring systems. So if I were to give you the cosine of negative 23 pi fourths. So if we add 2 pi here, we want to write this in terms of an angle that's between 0 and 2 pi. So if we add 2 pi here, we're going to do negative 23 fourths. When we add 2 pi to that, we're really adding 8 pi fourths. Right? So we're taking negative 23 pi fourths and we're adding 8 pi fourths, which gives us negative 15 pi fourths. Well, that's still not between 0 and 2 pi, but the cosine of negative 15 pi fourths would be the same as the cosine of negative 23 pi fourths. So I'm going to add another 2 pi. So if I take negative 15 pi fourths and I add another 8 pi fourths, which again is 8 pi fourths is 2 pi, so then that gives us negative 7 pi fourths. So that's the same as the cosine of negative 7 pi fourths. Well, that's still not an angle that's between 0 and 2 pi. So I want to add another 2 pi to the negative 7 pi fourths. But 2 pi is really 8 pi fourths. So if we add another 8 pi fourths, that finally gets us to an angle that's in between 0 and 2 pi. So then we have cosine of pi fourths. Pi fourths is in the first quadrant. That goes with root 2 over 2, root 2 over 2, because it's your middle finger. It goes down because pi fourths goes with 45 degrees. You've gone right and up, so they're both positive. The cosine is the x value, so I take root 2 over 2, and that becomes my answer. Okay. If I show you one other one, if we've got the cotangent of 10 pi thirds, okay, so again, we want to write an equivalent expression with the angle that's between 0 and 2 pi. So I'm going to take 10 pi thirds, and I'm going to subtract 2 pi. I'm subtracting 2 pi this time because it's past 2 pi. So if I take 10 thirds, we're going to subtract 2 pi. If we get a common denominator, that gives us, 6 pi thirds. So we do 10 pi thirds minus 6 pi thirds, which gives us 4 pi thirds. So then 4 pi thirds is in between 0 and 2 pi. So this is the same thing as the cotangent of 4 pi thirds. 4 pi thirds is 1 1/3. The reference angle is pi thirds. This one, which gives you 60 degrees, which is your ring finger. It goes down. That gives you 1/2. Root 3 over 2. We've gone left and down. Both are negative. Cotangent's the reciprocal of tangent, so we want x over y. It's the top of the x over the top of the y. So we get negative 1 over negative root 3, which rationalizes to a positive root 3 over 3. So that's how you can use your coterminal angles and your even and odd identities. I don't love to use it that way. I think it's probably longer that way, but it does help you see, first of all, that coterminal values are the same, and it does help you remember how you can utilize your even and odd identities. Although there are other ways that we also utilize those even and odd identities.